Alright, welcome back, grade 11s. Today we're going to do section 7.2, which is absolute value functions. So, please take your notes and copy this in as we go. Absolute value function is a function that involves the absolute value of a variable. So these ones have y equals something like 2x minus 3. So again, it's a function, so that means it has a y and an x and an equal sign. For all values of x less than 0, the y value is negative x. So remember we talked about how the negative actually makes the other negative positive. And for all values of x greater than or equal to 0, the y value is just regular x. So since this function is defined by two different rules for each interval in the domain, you can define the y equals absolute value as x as this piecewise function. So this is a new word for us, piecewise. So piecewise just means there's two different pieces. So again, we have x if x is greater than or equal to 0, or it's negative x if x is less than or equal to, not equal to, just less than 0. Now one other thing to note about this piecewise function is that the negative in front, remember when we did y equals ax, if the a value is negative, it flips your graph. So same thing here, this graph is flipped if there's a negative out front. So let's take a look at this example. Again, it's y equals absolute value of 2x minus 3. First, we're going to find the y and the x-intercept. So anytime you want to find a y-intercept, you set x equal to 0. So when I plug in a 0 into the x spot, I get 2 times 0 minus 3, which ends up being the absolute value of negative 3. But we know that that absolute value has to come out as a positive because it represents how far away it is from 0. So the y-intercept is at 3. The x-intercept, we set y equals to 0. So I go 0 equals 2x minus 3. But that falls into the piecewise section where x is greater than or equal to 0, so it's just regular x. So that being said, we can basically remove those absolute value signs to say 0 equals 2x minus 3. We then add the 3 over and divide out the 2. So 1.5 is the x-intercept value. So now we have an x-intercept and a y-intercept. So part B says graph. So when we graph this, let's think of it as if it wasn't an absolute value equation. So it's y equals 2x minus 3. This is a linear function that has a slope of 2 and a y-intercept of negative 3. So if I was graphing this at sort of negative 3, I'd go up 2 over 1, I'd go up 2 over 1, up 2 over 1, and we'd get something like that. Okay, but with the absolute value signs included, the part that is into the negatives down here actually can't be in the negatives because we know that there are no negative values with absolute value. So we're going to take that negative part, we're going to flip it upright. Again, looking back at our piecewise function, this part here represents the flip. So I'm going to flip the part that's less than 0 so that it is upright. So when I flip it, it then will pass through a y-intercept of positive 3, which is what we found earlier. So the graph that I end up with actually is a kind of V-shaped graph that has the x-intercept is the turnaround point. So 3 over 2 is my x-intercept, which is my turnaround point, and it has a y-intercept of positive 3. So now let's finish by taking a look at the domain and the range. Here my domain is everywhere, which means the domain is an element of reals. But the range is only from 0 and up. So we'd say that the range is an element of reals. The domain is an element of reals. The range is greater than or equal to 0. We also need to express this as a piecewise function. So I've written that here for you. The piecewise function is 2x minus 3 if x is greater than or equal to 1.5. That's referring to this section of the graph, because that's the function of the graph that was on the original line. So the line of y equals 2x minus 3. But on the other side here is where I flipped the graph. So remember that that negative means it's been flipped. So this section of the graph from the x-intercept of 1.5 and down has now been flipped. So we say that it's negative if x is less than 1.5, because that's the part of the graph that's been flipped. Now we're going to try the next one. Now the next one is a little bit different because it is quadratic. So this would originally look like an upside down parabola, but then again there's going to be a flipped section because we can't go into the negatives. So let's start by finding the y-intercept. So the y-intercept, we set x equal to 0. So we get 0 squared plus 2 times 0 plus 8, which means its absolute value 8, so just regular 8 is our y-intercept. X-intercept is going to be a little bit more complicated. Again, it's just 0 equals negative x squared plus 2x plus 8, but I don't need to put the absolute value signs because in the piecewise function, at 0, it's just your regular graph. So the first thing I would do here is factor out a negative. So if I divide everything by negative 1, we get 0 equals x squared minus 2x minus 8, which then I can factor to get x minus 4 and x plus 2. So I have two x-intercepts. One of them is at positive 4, and the other one is at negative 2. So now we have our x and our y-intercepts, so let's attempt to draw the graph. So if we plot our points on the graph, again we have a y-intercept at 8, and x-intercepts at negative 2, and positive 4, which means the vertex would be at 1, because 1 is halfway between negative 2 and 4, and if you plug 1 back into your original equation for the x's, you end up getting 9. So I have a vertex there at 9. So this is just an upside down parabola that looks something like that. Now, when I apply absolute value, I can't actually take this negative part. So the part that is negative, instead of actually hitting at 0 and passing through, it would reflect back upwards. So the graph of absolute value minus x squared plus 2x plus 8 would look like this green graph here, where it kind of looks like a W. So let's take the domain and range. So again, the domain would be everywhere, because x is an element of reals, but the range would only be where the y's are greater than or equal to 0, because again, it can't go in the negatives. Now let's look at the piecewise function. So here the piecewise follows the original parabola between negative 2 and 4. Again, that's where my original parabola was. So it's going to follow the original parabola path where x is between negative 2 and positive 4. However, it's going to be flipped where x was either bigger than 4 or x was less than negative 2. So again, that's just talking about this flipped portion right here to make up our piecewise function. Now I understand that we're going to need to try a little bit of this. So there is an assignment in your textbook. I would like you to please try these questions, do your best at them. They're a little bit tricky, but it also does force you to remember how to graph some of these original functions. Also remember, you can always check with Desmos, or you can use the textbook answer key to help you out. Good luck!